Okay, now we're going to do what we did in Excel, okay, in R. Okay, so we're going to do the lift, and for that, before we can get started, we have to run this code. Okay, I don't know whether this is going to work. Okay, so it's working. All right, good. Okay, that one. And then I need to read the data. Okay. And I need to partition and run the regression. And this is the Toyota data set. Okay, so I run the regression and then I compute the predicted values of the validation set. Okay. So we have to run all of this so that we are back to where we were when we left off on Tuesday. Okay? Once that is done, now we can generate the gain, the lift chart. So what are we going to do now? We're going to do all of these three charts. We're going to do the gain chart or cumulative lift chart, and then we'll do decile-wise lift chart, and then decile-wise cumulative lift chart, because all these three charts. Okay. And for that, we need the all right, so that hyphen line was messing up. Library gains. Okay, so if you don't have gains, then you need to install it. Okay. Now, gains library will give you, all right, so now we're going to run, we'll call it Toyota gains, or Toyota gain, okay. Oh, Toyota gains, okay. Then gains, there are two things that we have to provide. One is the actual Y value, and then the predicted Y value. So here in Toyota price is what we are trying to predict. So, and we're going to do this for the validation data set. So valid DF price. Okay. So that's our actual Y value. Okay. And then the predicted value for the validation set, okay, we did that right here. So pred VL has the predicted value for the validation data set. Okay? So these are the two things that we need, and if you run this, by default, it'll group it'll order the variables, okay, it'll sort the cases by Y hat, okay, and then it'll bunch them up into 10 groups as deciles. But for our first graph, we don't want deciles, right? Okay, this one we have to use all the cases. So we want as many groups as the number of observations. So we can say groups equal to, okay, there are 575 observations, so I'm going to say 575. But there is a problem here, because if you end up with the same Y hat, if there is a tie, it's going to give you a warning, okay, but that's okay. So it's just saying, so there is a warning, there are 3 ties, so it's giving you a warning. And then you get, so what do you get from that gains? Okay. If you look at Toyota gains, okay, if you click that, you see it is a list. Remember, our list is, you can have anything in the list. So we have all of these different items in the as results. Okay, so you have depth. So depth is your decile. Okay, as you're going down. Okay, now since we have 575, so you have depth of 1 is the first observation, depth of 2 is the second observation, depth of 3 is the third observation, and so on. And there are 572 because there are 3 ties for y hat instead of 575. But all 575 observations are included in the calculations. Okay, so how many observations are there at each depth? Okay, if you ran defaults, it's going to be about 10%. But here we wanted 575 groups, so each depth is going to have exactly 1 observation, except for there are 3 depths at which there will be 2 because of the ties. Okay, and then cumulative observation. So this is like in Excel when we did. So we have the how many cases are at each depth, okay, cumulative cases, and then you're going to have the y values, okay, mean response. Mean response is y bar. Okay, when you have only 1 observation, the y bar is just that observation. Okay, and then cumulative mean of response. Response is y. Okay, and then you have cumulative percent. You have the lift. You have the cumulative lift, and then mean prediction. Mean prediction is y bar or y hat. Okay, minimum prediction, maximum prediction, and then we have some more stuff there. Okay, so we don't have to worry about those.